in the test structure.
So I did a Bachelor of Engineering degree at McGill University, and after that I worked for 4 years in industry, actually in the steel industry in Hamilton, Ontario. And then I worked in New Zealand for a year at New Zealand Steel because I wanted a chance to work overseas. And then I came back and decided to go and do graduate work and did my PhD at the University of British Columbia in materials engineering. To be honest, I think a lot of kids don't know much about engineering, but I was fortunate because my dad was an engineer. So I learned a little bit more about engineering. He was actually a chemical engineer. So I learned a little bit about engineering from him, and I really enjoyed math and science, and I liked the idea of applying it to something practical. I was always interested in how we can apply science and math and things like that to something practical that can be useful by industry, and so that's really what got me interested in it. A lot of the things around us are limited by the materials that we use for them. And so if you can help develop and design new materials, then it will really increase, for example, the efficiency of engines and things like that. So many of the things we currently use are limited by the materials. And so that's what got me interested in materials engineering. So this is a research program I'm involved in. So as a professor, you teach, but you also do research. And this involves the largest aluminum sheet fabricator in the world, Novelis. And so what they do is they actually they roll sheet down into sheet products. So if you think about things like your aluminum foil, that would have been rolled down into sheets. If you think about beverage cans, metal beverage cans, those are all made out of aluminum sheet. Now this project I'm working on with them is quite revolutionary. It's something they patented about 3 or 4 years ago. And it's a way now to make a sheet that's a laminate sheet, so it's like a sandwich. And this is just an example right here. And what happens is when they cast it, so this is when they've got the liquid metal, they cast the liquid metal one next to the other so they can solidify together. And what happens is you can create a sheet now that has different properties. So here's what we call one alloy that has a certain chemical composition. Here's another one. And what it allows you to do is tailor the properties so that what you might have at the surface of the sheet is different than what you would have at the interior in terms of the properties. The difference in this is that you are creating the laminate sheet right from the beginning when it is first processed. So you go from the liquid and you solidify them together. So you make them a solid together. It's called co-casting, or fusion casting is what Novelis calls it. And then you have the laminate structure right at the beginning, and then you roll it together as a laminate structure. I've really enjoyed my career as an engineer, and I think it's a wonderful career. To study engineering in school is a great way to train your mind, how to think analytically and to be a problem solver. And so I know a lot of students don't know much about engineering when they go in, and they're a little nervous about, first of all, choosing engineering, because as kids they're not really exposed to engineers that much. You're exposed to doctors and dentists. But don't worry about that. It's a great way to train your mind, and it can be a great foundational career for doing all sorts of other things later on as well, whether it be medicine or law or teaching and things like that. We do a lot of our programming for kids going in kindergarten all the way up to grade 9. In fact, our flagship program is something called Engineering Science Quest. It's about 23 years old now, so it's a program we've been running for almost a quarter of a century. And that's a program where we run a summer camp for kids where they can come on campus and have a week's experience around science and engineering. If you have an opportunity, actually, there's some programs in high schools now where you can, through science fairs and things like that, work with a professor. And so the university professors are always open to doing things like that. So if you're particularly interested in materials, then you could contact someone and you could learn a little bit more about the kind of research they're doing in their labs, and have access and potentially to some of the testing equipment and things like that.